Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the heterocyclic heteronuclear aromatic compound. What do you mean by the heterocyclic aromatic compound? The classification of that aromatic compound that we have discussed in our earlier lecture or in our previous lectures. Heterocyclic compound means what? Heterocyclic compound are organic compound that contain a ring structure or containing atom in addition to carbon such as sulfur, oxygen or nitrogen as a heteroatom. And their significance, the significance of the heterocyclic compound also we have seen. 2/3 of the all organic compound are aromatic heterocycles and most pharmaceuticals are heterocycles, and one of the example also we have seen and which is used for the treatment of malaria for 4,000 years. And most of the heterocycles associated biological activities such as antifungal, antimalarial, antidepressant, anti-cancer, anti-malarial, anti-inflammatory, anti-oxidant, HIV. So that type of the biological activities shown by this heterocyclic compound. And also we have seen nomenclature of heterocyclic compound. And as we know that nomenclature means what? The systematic way of giving the name of the organic compound are known as nomenclature system. So in a heterocyclic compound, how the nomenclature systems are adopted or followed, that you can see over here. Number 1, heteroatom is to be counted as a 1 or as low as possible. See, this is when the ring aromatic compound containing as a heteroatom means heterocyclic aromatic compound, the number of that heteroatom should be given 1 if only one heteroatom is present, and generally you can observe, you can look at only one heteroatom such as oxygen, sulfur or nitrogen may be involved in the ring, and therefore that is called as a heterocyclic compound in addition to that carbon. And therefore if heteroatoms are there, and that is aromatic compound, or maybe as a non-aromatic compound, we are not going to study here non-aromatic heterocyclic compound, but here we are specifically focusing on aromatic heterocyclic compounds. So in aromatic heterocyclic compound, one of the hydrogen atom or more than heteroatoms, if they are present, it is numbered as a 1. That you should remember. Heteroatom should get the number 1. So, and that's the mentioning here, one heteroatom is to be counted as a 1 or as low as possible. Now the second, when there is more than one heteroatom, preference is given to oxygen, then sulfur, then nitrogen and then carbon. Remember, whenever there is a heterocycles are present, heterocyclic aromatic compounds are present, and as we know that frequently occurring heteroatom in the aromatic compound are oxygen, nitrogen and the sulfur. So people, while giving as a number, heteroatom should get the number 1, but if 2 two heteroatoms are present in the same ring, then which heteroatom should get the first number? So that's why there is a preference is given. So preference should be if oxygen and nitrogen are present, nitrogen should get the first number. Nitrogen first, then oxygen should get the first number. Oxygen followed by then nitrogen. And therefore that is a preference is given when there is a more than one heteroatom. Preference is given to oxygen, then sulfur, then nitrogen, and then carbon. I hope you understood the rule number second. When there is more than one heteroatom, preference is given to oxygen, then sulfur, then nitrogen, and then carbon. Look at the third one. When there is more than one heteroatoms, numbering should be as directed as possible from one to the other. And now let us look at as a fourth point. Substituents are numbered as low as possible. If that aromatic heterocyclic are compound, they are generally containing substituents, so that substituents are numbered as low as possible. Now fifth one, and is a very important one. Acceptable prefixes includes O means oxa, N means aza, S means thaya. These are the prefixes generally used here. Oxygen are present, then you can call it as oxa. If nitrogen, you can call it as a axa. S is present, then you can call it as a thaya. So these are the things. These are the point you should remember over here. Now the common suffixes for N and N heterocycle for partially unsaturated systems. H is used to indicate the location of saturation. That is a 6 number rule is there. What is that? Common suffixes for N. Common suffixes for common suffixes. Common suffixes for nitrogen or non-nitrogen heterocycles. H for partially unsaturated system. For partially unsaturated system HR systems. Let me clean here. N systems. N systems. H is used to indicate the location. H is used to indicate the location of saturation. And as we know that saturated and the unsaturated organic compound means what? Those organic compound containing multiple bonds carbon-carbon double bond or multiple bond, that type of the organic compound are generally called as unsaturated compound, and those organic compound containing single bond, that compound are generally termed as saturated compounds. So common suffixes for N and non-nitrogen heterocycles for partially unsaturated systems. H is used to indicate the location of saturation. And the seventh point, number 7 point, this is a 6 point, 7 point, Hertz. 7th point is a Hertz wisdom. Hertz Wiedemann. Hertz Wiedemann system of systematic name. Systematic name of heterocyclic compound. Heterocyclic compounds, and that is the 7. And Hertz wisdom nomenclature adopted by IUPAC. At here the Hertz wisdom system adopted by IUPAC, that we are going to discuss over here, because we are discussing the nomenclature system. So let's see that a nomenclature system for heterocyclic compounds. Hertz Wiedemann. Hertz Wiedemann system nomenclature adopted by IUPAC. IUPAC, as we know that, International Union of Pure and Applied Chemistry. Now let us look at here rings. Ring followed by saturated. Here saturated. Here partially saturated. Here is a partially saturated, then unsaturated. This is a table which I have made over here. Let's see. This is a table which I have drawn here. Suppose let us see here. Here is a ring, saturated, partially saturated and unsaturated. The ring, number of ring, if there is a 3-membered rings are there. Suppose let us see 3-membered ring, then we can call it as saturated urane. If partially saturated, there is no urine. Here unsaturated, that is urine. That is a name you have to give. If the 4th member ring is there, saturated, then you can call it as ethane. Then you can call it as a ethane. Last suffix should be ethane. If partially, then you can call it as a dihydro. Dihydro. If unsaturated, ETE. You can suffix should be ETE. If 5-membered rings is there, 5-membered ring, then you can have saturated olane, and partially saturated, you can call it as a partially saturated, you again dihydro, and unsaturated, then OLE. If 6-membered ring is present, then it will be known as enane. And if partially saturated, which is known as di or tetrahydro. And in unsaturated, the suffix will be ene. And if 7-membered ring, then epane. Then you can call it as a epane. And for partially saturated, it is also known as, once again, di or tetrahydro, and epene, that is epene. And the last one up to the 8-membered ring, then you can call it as ocane. And here ditetra or hexahydro. Ditetra or hexahydro. This is the thing, and here that is ocene. The last suffix is used over here. So these are you should remember how you can give the name to this particular heterocyclic aromatic compounds. Let us see some example over here, how we can able to give name of those compounds, that is a heterocyclic compounds. Let us see here. Suppose we have a compound, this one is a 3-membered ring heterocyclic compound, 1, 2 and 3, that is a numbering system. Heteroatom always get as a 1, and you should remember, if oxygen atom we can call it as oxa, if nitrogen you can call it as aza, and if sulfur then you can call it as a thia. These are the suffixes you should remember here. Now common name, the common name of this compound, common name would be ethylene oxide, or you can call it as epoxide. Then systematic name, systematic name, and systematic name of this compound will be, as we know that oxygen atom is there, so we can call it as oxa, plus It is a 3-membered ring, that is a Irene, right? Irene. And now you give the name, systematic name should be A is removed or discard from here, and whatever resulting is obtained, you can call it as a oxyrane. Then the name of this systematic name of this compound is a oxyrane. That is a systematic name of this compound. Remember this one. Now if there is a, let's move on to the 5-membered ring. That 5-membered ring, as we know that one of the aromatic compound, because we are going to study that are, this is a, as we know that the common name, I am using here short form, common name is a furan. We know that common name of this compound is a furan, and the SN I am using as a systematic name shortly here. So here oxygen atom, while numbering, it should get first, second, third, fourth and fifth. So now oxygen atom is there, so you can call it as a oxa, plus it is a 5-membered ring, and which is unsaturated. Then you can use as a OLE, right? Here is OLE. And now after combining these two words together, you remove this A, what is remaining? That is oxole, which is a name of this furan. That is a common name is a furan, but the systematic name or the IUPAC name should be oxole. Understood this one? Now let us look at one more example over here. Let us see, this is a, now you know that the common name of this compound, we know that this is a pyrrole, right? Common name of this compound is a pyrrole. Now for systematic name, you should remember whatever the rules we have learned earlier in our previous lectures. Here heteroatom should get the lowest number, or it should get numbered as 1. Only one heteroatom is present, and therefore it should get number 1, 2, 3, 4 and 5. Look at one position, that is, what is that? Oxa, right? Oxa plus, that is a 5-membered ring, that is Ole, right? Ole, and if combined together oxole, you will get as a oxole. Name of this pyrrole is oxole. Name is pyrrole is a oxole. Right? Or one H at one position, so you can call it as a azole. Oxa plus OLE, 1H azole. That is, N means Adza, not Agza. Adza. So make the correction over here, Agza. Oxole. Here not OX, here is a Z is there. Oxole. Here oxole. No, here is right. X is right. Here is no change. But in this case, here is a Aza. Aza means here azole. Or we can call it as a, this is a saturated hydrocarbon, therefore we can call it as 1H azole. Either you can call it as a this one, or you can call it as a, because this is a nitrogen atom at one position. Now one is a next compound, we have this one, yes, right? And here common name, as we know, that thiophene. Thiophene is the IUPAC name of this common name of this compound, but here the what we can call it as a systematic name of this compound 1, 2, 3, 4 and 5 at one position, that is a thia, right? Thia plus 5 member only, so we can call it as a thiol, you can call it. Now suppose we have a let us see another examples which are the common name and the systematic name we are discussing over here. So let's see one more example here, that is, let us see, we have this one, this is one of the example. Common name of this compound is a piperidine. The name of this compound is a piperidine. Now the systematic name, and the systematic name would be 1, 2, 3, 4, 5 and 6. At nitrogen is there, so you can call it as aza plus 6-membered ring, and the 6-membered ring, that is an unsaturated one, so we can call it as a enane, right? Enane, saturated one, enane. Piperidine, so here the systematic name would be, you remove this one, you will get azinine, that will be the IUPAC name of this piperidine, or the systematic name of this piperidine. So let us look at one more example over here. This is a saturated common name. Everybody knows the common name of this compound. The common name of this compound is a pyridine, right? The common name of this compound is a pyridine. Now the systematic name of this compound, you can see here, nitrogen atom should get the number 1, 2, 3, 4, 5 and 6. At one position nitrogen atom is there, so suffix you can use here aza plus, this is an unsaturated compound. If unsaturated compound is present, then we know that suffix we are using ene. So now azine, that is a IUPAC name of this pyridine. So in this way we have discussed the IUPAC name of this compound. Let us move on to the, I think these are the some of the example which we have discussed so far, how to give the IUPAC name of this compound. Let us move on to the one more example over here. So let's see. Suppose we have a compound like this so these are the whatever the essential compound required for as far as the T.Y.B.Sc is concerned. We have discussed those compounds in this period. So I think in the next lectures we will see the 5-membered ring, which is that is aromatic compound, and how do we synthesize that compound in the laboratory and their reaction. That kind of the discussion we will discuss in our upcoming lectures. Till then, have a nice day. Thank you.